CBT Nuggets JNCIS Security Series Screen Options. Well, our networks from the outside and within are under constant attack from denial of service attacks, flooding attacks, spoofing attacks, scanning attacks, fingerprinting attacks, and not just the servers and the hosts, but also the devices that are providing security themselves. So in this nugget of the JNCIS Security Series, we're going to look at the screen options of the Juniper SRX. Let's jump right into my SRX real quick and do a show config. And we've seen this several times. We've gone through this configuration. We've noticed this. And now it's time to actually start to dive in to see what we can do with this feature of the Junos SRX. It's right here. It's Security Screen. We are going to spend our time talking about this configuration here and also many things that we can add to this screen feature, which, as I alluded to in the introduction, is a way for us to create a countermeasure or a mitigation feature against a wide variety of flooding attacks, UDP and TCP vulnerabilities, spoofing, also known as masquerading, as well as evasive techniques. And again, these attacks are not just targeted towards devices in other zones, okay? Workstations and servers and laptops and end host. They're also attacks that are targeted towards the actual firewall itself. So we want to spend some time in this nugget breaking those down. Now, something I'm also going to do is I'm going to bring up another utility, just a second here. For example, here is a graphical version of Nmap called ZenMap. I'm going to get your hands on this, ZenMap. This is a great tool that does a wide variety of different scans, okay? For example, I can do an intense scan plus UDP against this host, which is a Windows 7 machine. So we'll just scan that, and while we're doing that, and we're doing is we're looking for open ports. For example, you can see this quite a few ports that are open here. We're also discovering other UDP ports, and this is done to do fingerprinting or information gathering. It's an attack in itself in the sense of you're looking for vulnerabilities, but it's also the early part of a structured attack. Okay, reconnaissance and information gathering is the early phases of a complicated structured attack towards systems. And you know what's interesting is these types of IP address scans and port scans, they're not as common as you might think against the perimeter of our network. Okay, the crackers out there, the black hat hackers, they've really kind of moved on to much more sophisticated and brutal types of attacks using things like the Black Hole Exploit Kit, which I think 2.0 is the version that's ubiquitous right now. There's also Backtrack, which is a Linux build. All of these things have things like Metasploit in them and tons of modules and really script kiddie tools that can do a wide variety of attacks. And we're going to talk about some of those in this particular nugget here. But as you can see, one of the things that we're doing right now is we're scanning this particular host to find out, well, you know, what ports are open, so what vulnerabilities are there. I can also use other techniques, and depending upon the way that this host at 0.13 responds, based on the way it responds, I can determine what the operating system is. I can make other determinations about the way its TCP IP stack is going to operate. So that's what we're talking about in this nugget. We're talking about building countermeasures and building screens of security against a wide variety of different attacks. Information gathering attacks, reconnaissance attacks, and also the early phases of more advanced persistent threat attacks that are well structured, coming from the inside of our network and from the outside of our network. Now, here's kind of a laundry list of the types of attacks, and these can be not just malicious structured attacks, but these can also be, you know, because of misconfiguration, rogue devices, for example, or just end users in your organization that are running script kiddie tools or programs. They're just messing around, they're just being mischievous, or they do it by accident. Bottom line is, they all have similar results. Now, I'm not going to spend 5 minutes on each one of these because we're going to actually go into the configuration of how to mitigate these when we get to the CLI. But let's just say this, that IP as a protocol is really promiscuous. It was designed to be able to encourage and facilitate communication over networks. So it has vulnerabilities that are kind of inherent and built in. And you have to overcome these vulnerabilities with tools, for example, like screens and IDP that we'll look at in the next nugget, because we're not going to rewrite or change the IP version 4 protocols. As a matter of fact, IP version 6 has a lot of the same vulnerabilities and even some new ones because of multicast addressing that have been introduced. Okay, so this behavior is not going away, but it's just the price that we pay for having communication systems. Okay, so you have malformed packets, which are basically not adhering to the request for comments, or the RFCs, for the different applications and services that use the IP protocol. These malformed packets can take advantage and do buffer overflows. They can take advantages of weaknesses in TCP/IP stacks. They can be used to wreak havoc on a CPU or operating system. They can also be used to crash systems as well. So we want to be able to block those or create thresholds, because you never really completely eliminate these types of attacks. Sometimes all you can really do is just reduce the amount with thresholds. You have fragmented packets. As you probably know, when an IP packet goes from one network to another network that has a different MTU size, a different maximum transmission unit, either because you're adding encapsulation to it or you're doing some other type of physical network, for example, from a FIDI ring to an Ethernet, for example, you'll have to fragment the packets, take the larger packets and break them up into smaller IP packets. Well, that can actually be used as an attack, because the intermediate device, like the firewall or the IDP sensor, is going to fragment or reassemble differently than the target server or the target host. So malicious users and crackers can take advantage of that, and they can have it reassembled on the target server or the target system and actually cause some major problems. Fragmented packets can also be used to circumvent firewalls and IDP sensors. Also, spoofed packets. Okay, we don't want users on the inside of our network spoofing or saying that they're the source of an IP address that's actually on the outside of our network. We don't want them masquerading as some public device with some made-up IP address, nor do we want users on the outside of our network in the untrusted zone to be able to masquerade or spoof themselves with a source IP address that's actually on the inside of our network, or maybe spoofing the IP address range which is in the DMZ. That's one of the main reasons why malicious users are going to try to scan IP address ranges to discover what IP addresses you're using in your DMZ or in your inside network. Another reason why we use network address translation to hide that. So if they can discover that, they can usually guess that the lower numbers of the subnetwork, dot 1 is the default gateway, dot 2, dot 3, dot 4, or our servers or printers, they can get information, okay? And so they can spoof and masquerade as one of those legitimate hosts. Okay, we don't want them inside of our network pretending to be a DHCP server or a DNS server or a default gateway. Okay, it's a bad thing. We can also see abuse, misuse, and flooding of ICMP packets and flooding of TCP, for example, SYN floods or SYN-FIN floods. And we'll talk about some different granular types of this misuse and flooding as we actually get into the code in the CLI to block it and countermeasure it. You can also do UDP flooding. UDP is used a lot for ping pong services, right? I want to do queries. I want to do updates. I want to do keep alives. Well, you can flood devices and you can force their CPUs to have to handle all these UDP packets. And so usually if you have a bunch of UDP packets flowing in one direction without any return traffic, that's usually a sign that it's a flood attack. Then there's different denial of service attacks. This is more of a generic term because you can misuse UDP or TCP or ICMP to basically deny services. So a denial of service can use a lot of different threat agents or attack vectors to actually deny services. So what you're doing is you're saying, I want to prevent this server or this router or this switch or this firewall from doing what it's supposed to be doing, because it has to handle this malicious traffic or this flood of traffic. And in a sense, its CPU, its memory, those are being used for illegitimate reasons, illegitimate services, and then we're denying actual services to real hosts and real client-server relationships. So this is kind of a quick little list of the things that we're going to be mitigating against with our Junos screens. Now I'm using RDP to connect over to I have a forensics machine. It's basically a high-end laptop with a ton of RAM on it and a bunch of code. It's my forensics system. Well, I've got it dual booting between Windows 7 and Backtrack 5, which is Ubuntu Linux. What this is going to show you here, and it's not that easy to RDP to Ubuntu. You have to run a particular module, and it may not look as good as going to a Windows machine, but like you can see down here, it looks kind of bad. But the bottom line is, what I want to show you is how easy it is for people on your network to just come and get access to these tools that can do not only reconnaissance attacks and flood attacks and denial of service attacks, but a wide variety of things. If you go up here to Backtrack, you can see that, and this is readily available on the internet. There's YouTube videos that show you how to run this. I mean, you can basically run this from a CD. You can put a CD in your CD-ROM or a USB or some other removable drive. You can basically run Backtrack 5 and just write in memory and run these tools and get them onto the network. So you can see information gathering tools, network analysis tools, all of these things. You can see identification of whatever IPS module is out there, identifying live hosts. Look at all the different ways that we can do this. Okay, by the way, here's the Nmap that I was talking about. I'm using this ZenMap tool, and this is just one of many tools. You can get ZenMap by itself, or you can go and ARPing, all these different tools, NetDiscover. It's just amazing what people have. They can also run network scanning tools to map out the LAN, to identify IP address ranges. I talked about that. There's network traffic analysis tools. Wireshark and T-Shark are probably two of the best. If they're able to pull information off the wire, they can analyze. So if you're using clear text protocols like HTTP or Telnet or FTP and others, then they can just basically look at it. OS fingerprinting. So here's Nmap again and other tools, Xprobe 2, that can be used to do the types of scans like we just talked about. And like I'll be showing you how to countermeasure here in the SRX in a moment, okay? Using traditional methods like TCP fin scans and things like that. You've also got service fingerprinting, so you can fingerprint different services. NCAT is probably the most popular service fingerprinting tool out there. HTTP print also very popular. And then of course you can analyze Windows environments with SMB analysis, SMTP environments for your email or Exchange environments, SNMP, a very vulnerable protocol that can be compromised, and this is an analysis tool for that. You've also got other tools for secure socket layering, SSL, TLS, telephony, VoIP, and then VPN analysis. Okay, so these are just the tools that are under information gathering. Okay, that doesn't even get into wireless analysis tools, database analysis tools, Oracle, MySQL, Microsoft SQL, web application analysis, and then there's vulnerability assessment tools, exploitation tools. So these are the kind of things that your end users in your organization have readily available, okay, that they can just basically run off of a CD-ROM, off of a removable drive, or they can install it in a dual boot environment, which is what I have on my system here, and run things like Backtrack. There's also Black Hole Exploit Kit, which I think I can go down here and get onto the internet right from here. There we go. Conqueror. Let's go Google. It doesn't look very good, but let's go Google. That's my URL. I don't want that. I should be able to Google right from here, but let's just do this. And let's see if we can. Not showing up very well. Okay. Let me get out of this RDP session. Bring that in here. Let's go ahead and Google Black Hole Exploit Kit 2.0. This is brutal software. Okay, this talks about. It was just released, I think, in September of 2012, and this is the second version of it. I would go up and maybe go here and search for Black Hole Exploit Kit, threatpost.com. And by the way, one of the things we're going to look at later on in this Nugget series is how to countermeasure these SQL injection attacks. Okay, we'll look at a gateway to do that. It's a very common method, still used out there. What's so brutal about this black hole exploit is that you can go and you can pay, $1,500, right, to get a 1-year license to get unlimited domains that you can spoof, random URLs that you can basically masquerade that your code is operating from. So, and this is a huge exploit. This isn't the only one out there. Okay, there's Siberia Exploit Kit, and as I mentioned, Backtrack and Metasploit both have tons of tools in them. I think Backtrack 5 we just looked at also has Metasploit in it as well. So, that's something to keep in mind. Let's talk more about screens, and we saw this very briefly in the CLI in Junos on my SRX, and we can see that obviously they're configurable, right? So we can enter commands in a policy-based format to configure all different types of screens for different scenarios. They're also built into Junos, so it's a built-in protection feature. We can implement screens, and we have some defaults, but we can implement even more advanced screens at the enterprise edge or service providers on larger SRX platforms, even on our routers as well. Okay, so these are supported in Junos, so your Juniper routers and other devices can also support screens as well if they're a perimeter device or a customer edge device. But we can also deploy screens in internal zones to get added protection, right? Because we might want to protect our call center or protect a research and development building or things like that. So different zones can have screens to protect them from attacks as well. Because remember, attacks can happen from internal users, right? We have to keep that in mind. We also want to be able to detect and prevent several categories of malicious attacks and suspicious traffic. Okay, it may not be purposeful. It might just be a misconfiguration that's causing the problem. It could be a rogue device that's not necessarily a device that's meant to do harm, but it's an end user who's running some program either without their knowledge or intentionally on their laptop, for example, that they brought back into the office. These checks happen very early in the packet processing. Let me show you what I mean. Remember this diagram from earlier on in this Nugget series? Well, remember we have the ingress packet, right? It looks for a match. If there's a match, it's going to go to the fast path, right? If there is no match, it's going to go through the first path. But notice that whether it's the first path or whether it's the fast path, the screen check is the first thing that happens. Okay, so earlier in this Nugget series we looked at things like doing route lookups and policy lookups and NAT. We also talked about VPN services in the previous couple of Nuggets. Well, all of these things happen after the screen check. This is the first thing that occurs, either the first time the packet's coming through or if there's a match and it's on the fast path. Continuing on with our discussion of screens, realize that screens go beyond just what a basic firewall filter does, because they can look deeper. Actually, they can offset into the actual data portion of the packet. So they can do deep packet inspection, right? More than just a firewall filter. But there's a downside to that. Using screens, and if you have a pretty elaborate screen policy, as we're going to see, it's pretty processor intensive. Okay, so we need to be kind of careful, especially in our lower end devices. But the lower end device, the lower end SRX like my 210, is going to be implementing the screen in software. Once you get up to the higher end platforms, the high end SRXs, they're going to do theirs hardware based. Okay, so that's a major advantage to using the high end devices that you would use for the large enterprise or service provider. Now, the types of script kiddie tools and modules and code, malicious code that's used to attack the devices behind our SRX, as well as the SRX itself, is readily available. Let me show you what I mean. Okay, the first thing we have to do is kind of get into the context where we're going to set our security screen. So in configuration mode, I'm going to set my security screen, And the key command here is IDS option. Okay, what it wants next is a name for this screen. So let me just say this is an internet screen because I basically want to, I don't know, have a bunch of screen options for traffic coming from the internet in the untrusted zone, right? So that's what I'm going to name it. Now, put in a question mark here, and now you're going to see a lot of the different services that we're going to provide protection on, okay? You can see that we have the ICMP options, we have IP options, we have more granular TCP and UDP options. We also have the limit session. We'll be looking at the limit session here at this level in JNCIS security, but we will be talking about these four main categories: ICMP, IP, TCP, and UDP. And on the exam, you want to make sure that you're familiar with some of the options that you can do in each four of those categories. Now, one of the most common areas of vulnerability is definitely ICMP because the message types can be used for a wide variety of denial of service attacks. The ICMP information that is sent back and error messages can be used as fingerprinting, it can be used as reconnaissance. Just the nature of the behavior of the way that devices respond to ICMP messages and the way they respond with TCP can be a way to fingerprint the operating system, for example. So one of the first things we're going to do is we want to create a sweep screen. So we want to have a threshold. We may only want to have a certain number of ICMP packets per milliseconds, for example, or we could have a certain number per second, okay? The larger our threshold is, the longer the time and the less ICMP packets that are allowed, right? So let's go ahead and do ICMP right off the bat here, and we'll say my options are, let's look at IP sweep, okay? The IP sweep option. And let's set our threshold. Now this is done in microseconds, okay? So that's the weird thing. Let's actually do a question mark here. 1,000 to 1 million microseconds. So 1 million microseconds is 10 ICMP packets. So we can say 10 ICMP packets in 1 million microseconds, that's 1 second. Let's go ahead and put that in there. 1, 2, 3, 1, 2, 3. You know, if there's an individual host that's sending that, that would be quite a bit, okay? So that's probably a good one to set. Now, something else I want to do with ICMP is I want to protect against large ICMP packet floods or ICMP fragmentation attacks, okay? So I can do this by going back to my ICMP context and just issuing the fragment command, and that's going to deal with my fragments, and then I can say I want to prevent large ICMP packets as well. A couple things I want to do there. Now I've already set up my ICMP IP sweep threshold to 1 million microseconds, okay, so basically 10 per second. That's from an individual host. But what about flood attacks, okay, from a bunch of different hosts? Because there's users out there that can get things like the black hole exploit kit, or there's several modules in Backtrack, including Metasploit, that can do this and send from random IP addresses. So I might want to configure an overall threshold, let's say for maybe 7,500 ICMP packets per second. That's total packets from any source, okay? So I can do that by staying here in the context of internet ICMP, but we're going to say the flood threshold. And what makes this kind of confusing is that the IP sweep threshold is in microseconds, but this setting is basically how many packets per second. Bottom line, we're going to say 7,500. Okay, those are our ICMP countermeasures with our screen. And we can go ahead and commit those. And let's say do a run show config. Now here's our screen, and we have the internet option, and there are 4 ICMP settings. You can also notice there's some default. There's the ping of death ICMP, which is already set in the untrusted zone. There's a teardrop attack. These are old historical attacks that have been around for years and years. Nobody really launches them anymore. You might have somebody in the inside of your network just goofing around, okay? But that's where we can come back and we can see our internet screen. Let's go back and configure some more things there though. Let's go ahead and do the edit security screen context. Get into that context. Now we can just say I want to set the IDS option, and let's do IP next. Okay, we've done ICMP. Let's do IP next, and it's internet. And we can see that, like I said, we already did ICMP. We'll put in IP. Now, one of the things about IP we need to do is what you see are some things like bad option, record route option or record route option, source route option. One thing to know about IP version 4 is there's actually a bunch of capabilities to use these IP version 4 options. We don't use them anymore. Okay, they were used early on in the early days of the internet. Now they're all just basically vulnerabilities. Okay, any of those IP version 4 options. As a matter of fact, those were removed from IP version 6. IPv6 does not have options anymore, like the ones we see here. It does have extension headers, and that, of course, does introduce some of its own vulnerabilities, but nowhere near the kind of problems we had with these IP options. Most of your operating systems, by the way, whatever the vendor, Juniper router, Cisco router, any type of sensor, server operating systems, they're not going to basically allow these types of options to crash their systems like they have historically, but it's a pretty good idea, especially inside your organization, to make sure they don't get to your end hosts and to block those packets. So for example, this bad option here is going to pretty much block malformed IP packets, right? So we can do that by just saying IP bad option, and we're turning on that screen. Along those same lines as a malformed packet, we want to block IP packets with an unknown protocol identifier, right? So that would be, as you can see on the list there, unknown protocol. Okay? So those are just a couple of them. I'm not going to do all of them. Something else that I want to see done is this spoofing. Okay? I mentioned what spoofing is, and spoofing is going to use a feature known as URPF. Okay, unicast reverse path forwarding. Basically, it's going to look at the routing table and determine that the source IP address in the packet header is actually valid based on the routing table. And so it can determine from that information if it's a spoofed address or not. So for example, a packet's coming ingress or inbound on the untrusted interface from the internet, and if the source IP address in the source field is actually an IP address on the inside of our network, it's not a route that is attached to the outside zone or the untrusted zone or that interface or interfaces, then it knows it's a spoofed packet. Okay, so we want to go ahead and turn on that feature, and that's IP spoofing. So for the exam, for example, I want you to know, got to spell that right, that this set IDS option and then the name of your screen IP spoofing under the edit security screen context, this basically turns on reverse path forwarding loose checking. Okay, loose checking. So there we go. We got that feature. Okay, so that is, we can even do a show here, by the way, and we can see what we've got. We've got ICMP. We've got some countermeasures there. We've got some screens for IP. Okay, non-conforming protocol options, unknown protocols in the IP header, spoofing or unicast reverse path forwarding. So there we go. Let's do TCP next. And TCP, boy, there's a whole lot of stuff we can do there. We'll keep it simple because there's obviously a lot of advanced techniques you can use. Now we can see down here, by the way, in our untrust screen by default, okay, that there's already quite a few thresholds that are in there for SYN flooding. So this is a SYN flood attack. This is when somebody uses many script kiddie tools to send TCP segments or packets to your SRX or beyond the SRX that are basically saying, I am a SYN packet, I'm a synchronization packet responding to some initialized TCP three-way handshake. Well, of course, that doesn't really exist, so I'm flooding you and I'm forcing you to have to respond. Okay, so you can see there's already some values that are set up here. Now earlier I showed you that Nmap or ZenMap, the graphical version of Nmap, which could do TCP sweeps or UDP sweeps, basically looking for open TCP ports and open UDP ports. And we found those on that one host. Well, I might want to create a threshold to mitigate against those. So I can go ahead and set my IDS option internet. Let's go ahead and do them for both TCP and UDP while we're here. So we'll say TCP and then TCP sweep, and we'll do the threshold, and we'll do it the same. It's in microseconds, so we'll do the same thing. 1 with 1, 2, 3, 4, 5, 6 zeros. Okay, we'll do the same thing for UDP. Okay, beautiful. So now we can protect our zones, okay, from the outside if someone's using Nmap or ZenMap and doing one of those UDP port scans or TCP port scans. Another type of port scanning is a fin scan. Remember, the TCP protocol has a finish flag that can be turned on, which is the fin bit, which basically says this is the end of a conversation. Well, if somebody sends a TCP packet that has a fin flag turned on, it sends it to a port, it will listen for the response. Okay, what happens is the end host is going to assume that there's a listening socket. So it sees the fin packet for a particular connection. It doesn't have a connection established, so it responds with a reset packet or a TCP with the RST flag turned on. Well, that information can be used as port scanning. Okay, it's part of reconnaissance. So that's a very common attack. So we might want to go ahead and say we don't want to allow those. We want to block that type of scan, fin scan. So we do that by going back to TCP, and we'll just say fin no ACK. And I'm pretty sure that one will be on the exam. There's a couple of more here, by the way, that we need to look at. Let's do a question mark. Notice that we have a scenario where you might have the fin flag but not the ACK flag set. Okay, so we want to prevent TCP packets that have no flags and the SYN fin flag set. So no flags is kind of a null attack, is what we call it. Flags that have the SYN fin, in other words, you can't have the synchronization and finish at the same time. That can't happen. That's also called a Christmas tree. Realize that there's only a certain number of valid values here. So a couple of these I want to run is this TCP no flag. That's basically the null attack. So let's go ahead and put that one in there. And we don't want to see the SYN fin. Okay, that's this one right here. So let's go ahead and do SYN fin. Next, let's do a denial of service countermeasure that actually is kind of old school, but it's resurfaced. It's reared its ugly head again in Windows 7. Okay, it's called the teardrop attack. And actually, it's been seen in Windows 7 to attack the SMB2 protocol. Basically, it's two fragmented packets that overlap each other, and then the Windows 7 machine reassembles the two fragmented packets, and it crashes it. So how do we countermeasure that? Well, we want to go to Internet and then IP teardrop. Okay, so we've got ICMP countermeasures, we've got IP countermeasures, we've got some TCP countermeasures, and we've got the anti-denial of service, anti-teardrop. What about UDP? Well, let's do a UDP flood threshold. Okay, so we're going to, I'll just basically start over and do set IDS option internet, and it's going to be UDP flood, and then our threshold, let's say, how about 50,000? This is also in packets per second, so we'll say 50,000 packets per second, and we'll go with that one. Okay, let's do a show and wrap up what we've done here. Okay, we've got some ICMP screens, those 4 options. This is it from an individual host sweeping. This is our entire flood threshold, 7,500 per second. No fragment, no large ICMP packets. We've got a couple of IP options, and usually you want to go in and countermeasure all the IP options, but we got a couple of them here. We have bad options and unknown protocol. We've also got anti-spoofing and the anti-teardrop. We see in TCP we're looking at some illegal TCP activity as well as a threshold for TCP sweeps, and then we've got a flood threshold and a UDP sweep threshold. All right. Now, just because we have this screen called Internet doesn't mean that we actually have applied it to any zone yet. I've scrolled down here into my different zone. You can see in Security Zone Untrust, by default, that screen, Untrust screen that we saw earlier, is already applied. Okay, so in this particular device, it's applied to that interface. So I need to know the command that I would use to apply the Internet screen to a zone. For example, like the Untrust zone. Let me show you that command. Now, I'm not going to apply this particular screen. However, let me show you the command we would use to do that. Okay, so I want to set security. I think you know where I'm going with this. Set security zones. Security zone. In my case, the Untrust zone. Then we want to apply the screen, and mine was called Internet. Okay, so that's the command. Set security zones, security zone, followed by the name of the zone that you want to apply the screen to, screen Internet. And I could remove this particular Untrust screen if I wanted to. Or I could just configure different features in it and both of the screens would apply. Remember, they're going to be early on in the processing. If I wanted to delete this screen, I would just delete security zones, security zone, Untrust screen, Untrust dash screen. Right on? Now, if I want to see, and I'm not really hitting anything against this particular device, but let's go up one level. If I want to actually see some statistics, the command to see if there's any hits would be show security screen statistics, and then the interface would be, in my case, fast 00. And I'm not going to have any, okay, but I want you to see the kind of things that show up on the list. Now, I could do a proof of concept on this, definitely. If I were to go ahead and apply, and you might want to test this on your own, okay? Because I've shown you all the tools that you need to play around with this. So you could simply go in and use what I showed you, apply those to an interface, and then you could use any of the ScriptKitty tools I showed you. You can go get Backtrack. You could use ZenMap, the GUI version of Nmap, and you could actually hit this interface and you would generate statistics, okay, for all these types of things. Now, we didn't talk about every single thing on this list, okay? But I mean, a lot of these things are just IP options that we don't use anymore. I showed you how to do a couple of them. You probably want to go ahead and, make sure that you're protecting against all of these. There's also a TCP land attack. Didn't really mention that either. Now, the reason why I didn't configure the land is because it's already part of the default screen, okay? But this is a, blast from the past, okay? It's like the teardrop attack. Bottom line, it shows up every once in a while. It showed up again in Windows 2003, for example. It's basically a SYN packet with a source IP address and port that's in the same as the destination IP and port. So the thinking here is that when the destination IP tries to process the packet, it'll cause some unexpected result when it notices that the packet comes from itself. Okay, so typically, like I said, this will be caught. It's an old school attack and it's part of the default. That's why I didn't mention that one. But you can see most of these we countermeasured. TCP WinNuke, really old, been around for a while. So this as you can see, the screen methodology here is kind of our first line of defense after we do the firewall filters or our access control lists, right? Our firewall filter policy. Then, after we apply the screens, the next logical place to move from there would be intrusion prevention and intrusion detection, which is exactly why it's the nugget that comes up next after this one. Well, I hope you enjoyed the screen options nugget of the JNCIS Security Series. I hope it was informative for you. I want to thank you for viewing.